Okay, rational functions day 2 for the bajillionth time. Rational functions, f of x. I uploaded these notes, but I want to explain them, and I tried many times. Hopefully this will work. F of x is equal to p of x over q of x, where two functions, two polynomials, divide out, and q of x cannot equal 0, otherwise this will be undefined, this function here. So we want to simplify the function first, then look for x-intercepts. So these are all clues on how to graph. So we simplify the function first, we look for x-intercepts to see where the graph goes to the x-axis, we look for horizontal and vertical asymptotes to see where the graph approaches. We find the vertical asymptote by solving the denominator equal to 0. We solve for the x-intercept by setting the numerator equal to 0. We find horizontal asymptotes by comparing the degree of the numerator to the denominator. So that means the highest power to of the numerator and the highest power of the denominator. We compare the two. And if the numerator is greater, that means the numerator is going to grow too big and it won't reach a limit. So we're going to have no horizontal asymptote, so no horizontal line that stops the graph from growing. Whereas if the denominator has a higher degree, the denominator will get larger first, which means if a fraction has a denominator growing larger than the numerator, eventually it's going to approach 0, and that's why you have the x-axis or y equals 0, a horizontal line there. And if the degrees are the same, then it's going to be a horizontal line, y equals the ratio of the coefficients on the front. So if you have 3x squared over 5x squared, 3/5 would be the y equals 3/5 would be the horizontal asymptote there. And holes in the graph are places where the graph is undefined. So we'll see like a little circle, and that's going to happen when we divide out a common factor. So we'll see examples of that. So down here, an example. So we're looking at the x-intercept. That's where we set the numerator equal to 0, and it's going to be x minus 4 equals 0, x equals 4. So that's why we have 4 comma 0. That means the graph must go through that point right there, 4 comma 0. The denominator we set equal to 0 for the vertical asymptote. That gives us x equals negative 4. So x equals negative 4 is this vertical line right here, a vertical asymptote. And then the horizontal is looking at the ratio of the coefficients. It's 1 over 1 because they're the same degree. So we just take the ratio, which is 1. So y equals 1, and that is our horizontal asymptote. So there's no hole because there's no factor that we divide out after simplifying. So there's no hole. And our domain is anything but x could be anything but negative 4. And our range, y could be anything except positive 1. Now, for this function here, it's a reciprocal function shifted down 2 spaces. Actually, that's not the right one, is it? Let me take a look at that. Hold on a second. So many pages, so little time here. So, number 2, solving the numerator equal to 0 gives us x equal 3. So x equal 3 is where the x-intercept is, 3 comma 0, right there. Our vertical asymptote is setting the denominator equal to 0. Because that's going to make a vertical line that's going to divide the graph, where the graph kind of disappears, and that's x equals 1. And so x equals 1 is our vertical asymptote right here, all right? And then we're looking for the horizontal asymptote. That's we look at the ratio of the degrees. Now in this case, the degrees are the same, first power, so it's just 2 over 1. So therefore, 2 over 1, so y equals 2, and that is our horizontal asymptote right there. Now there is no hole because I didn't divide out any common factors, and domain x could be anything but 1, and range y could be anything but 2. Going down to number 3 here, we simplify as much as possible as the steps on the first page of the notes. We can divide out x minus 1s, so therefore x equal 1 is where the hole is. So that's why there's a hole in the graph right there, because right at 1, that makes the denominator equal to 0. Okay, so the hole is at 1. Now, how do you find the y-coordinate? You put the 1 back in to the expression after you simplify. 1 plus 1 is 2, so therefore 1 comma 2 is the exact point where that hole is. Now, how do you get this? Well, that's the line y equals x plus 1. You get that from simplifying x minus 1s. So you have y equals x plus 1, which is this line right here. Now, there is no vertical asymptote, horizontal x-intercept. Yeah, x-intercept is negative 1 because negative 1 makes the numerator 0. Negative 1 comma 0 right there. No vertical asymptote because the denominator cannot equal to 0 now. The horizontal asymptote because the numerator has a higher degree, so there is no horizontal asymptote. The domain x could be anything but 1, and the range y could be anything but 2. Down to number 4, we factor out the numerator and denominator. We can factor out x plus 5, which means x equals negative 5 is where the hole is. That's why there's a hole right here. Okay, so therefore you plug negative 5 back in here, and you get negative 1. So therefore negative 5, negative 1 is where the hole is, right there. And then the x-intercept, there is no x-intercept because we cannot make the numerator equal to 0. Vertical asymptote, negative 4 makes the denominator equal to 0. Horizontal asymptote, the denominator has a greater power, or a greater degree, so therefore this goes to 0, y equals 0, that's the x-axis. Okay, that divides the graph. And domain x could be anything but negative 5 or negative 4. It can be negative 5 or negative 4 because the whole is a negative 5 and negative 4 makes the denominator equal to 0. Y cannot be negative 1 or 0. It can't be 0 because that's where the asymptote is, and it can't be negative 1 because that's where the hole is. Down the bottom here, we factor the numerator and denominator. There are no common factors, so there is no hole. The x-intercepts, we solve the numerators for 0, and we get negative 1/2 and 1, so that's where the intercepts are, negative 1/2 and 1. Here and here, it's hard to see that. My graph is not perfect. Sorry I didn't take more time. But vertical asymptote is 4 and negative 3. Those are the places where 4 and negative 3, the vertical asymptotes right here. Horizontal asymptotes, well, they're the same power, so we look at the ratio 2 over 1, so y equals 2 is the horizontal asymptote right there. There is no hole, we said, so y domain x cannot equal 4 or negative 3. Range, now the range, y cannot be, y has to be either above 2, right, above 2 here, or below 1/12. And how do I get that 1/12? I have to find this maximum point of this graph right here, because you see how y is everything from here down. So how do you do that? I put a 0 in here, and I got 1/12. So that means that y is going to be less than 1/12, because I knew that was the highest point right there on the the intercept right there. That's actually the y-intercept. I didn't draw that graph correctly, but it's the y-intercept. 0, 1/2. Okay, so that's why that is. The rest of these here, let's take a look. We factor out x plus 3. After we factor this, we can factor out x plus 3, which means our hole is at negative 3. We put negative 3 back in here, our remaining quotient, and we get negative 9/4. So let's look for the x-intercept. That's the only thing that makes the numerator 0 is 0, so it's 0, 0. The vertical asymptote is x equals 1, and that's because that's the only value that makes the denominator equal to 0. So we have x equals 1 as our vertical asymptote. Horizontal asymptote, there is none because the numerator has a higher power than the denominator, so there's no horizontal asymptote. We did the hole already. X could be anything but negative 3 and 1. Y could be anything less than 0 here, and greater than, let's see, y cannot be equal to negative 9/4, and y has to be less than less than 0, greater than 1, 2, 3, 4. I think that's a 4 right there, and y cannot equal negative 9/4. Again, how do you get these exact curves? You plug in, you put in points that come out easily. So you get better at that. You plug in like a 2, a 3, or 4. So you put a 2. You put a 2, for instance, and you get 4 over 1. So that's why that's the 0.24, and that's why y has to be 4 and above. If you put another number in here, like 3 or 4, you'll see the graph goes up like this. So that's trial and error, but then you get the general shape. You know it has to obey these asymptotes. Moving on here. You're going to factor out x minus 6. So x minus 6 is factored out, which means x equal to 6 is where the hole is. And we put 6 back in, you get 1/6. So 6, 1/6 is right there. That's our hole. None. So the x-intercept has none because you can't make the numerator equal to 0. The vertical asymptote is 0. That's the only thing that makes the denominator equal to 0. So that's why there's a vertical asymptote right here. The horizontal asymptote is the ratio. We look here and we see that, okay, so the degree is higher in the denominator, which means that this is going to be y equals 0, the x-axis. X could be, for the domain, x could be anything but 0 or 6. It can't be 0 because that's the asymptote. Can't be 6 because that's where the hole is. Range, y could be anything but 0 or 1/6, because 0 is where the asymptote is, and 1/6 is the y-coordinate of the hole. Going down to number 8. Number 8. You factor out the numerator and denominator. You see you have x plus 7 in commons. That means -7 is where the hole is. That's this hole right here. So -7, and then you put -7 back in here, and you get 11 halves, which is 5.5. So therefore, we look for x-intercept. X-intercept is going to be 4 comma 0, because that makes the numerator equal to 0. Vertical asymptote, that's where the denominator is 0, so we have -5 makes this 0, so x equals -5 is my vertical asymptote. My horizontal asymptote is at 1, because my degrees are equal, and my ratio is 1, so that is y equals 1. There we go. And so we have the domain with the range. And then I did that already. Oh, so the domain, x can't be -7 or -5, because that makes the denominator 0, or that's where the hole is. And so we have, that's where the asymptote is, and that's where the hole is. And y could be anything except 1 or 5.5. It can't be 1, because that's where the asymptote is. It can't be 5.5, because that's where the hole is. And the last problem for number 9. Number 9, after you factor out x plus 1, that means -1 makes that 0, so that's why the hole's at -1. You put -1 back in, you get -3, so the hole's at -1. -3 right there. The result is a line, so with the slope of 1/2, and a y-intercept of -5 halves, so that's why I have the line with a hole right there. Our x-intercept is 5, because that makes the numerator equal to 0. Our vertical asymptote does not exist, because we can't make the denominator equal to 0. The horizontal asymptote does not exist, because the numerator has a higher power than the denominator. We did the hole already. The domain, x could be anything but -1. The range, y could be anything except -3, because that's where the hole is. Over and out. I hope this works.